The velvet expanse above, a canvas dyed in the deepest indigo, stretched out over the quiet summer field, studded with an uncountable scattering of diamond points, each a distant sun, a colossal furnace dancing a silent, fiery ballet across the gulf of infinity. We habitually regard these stellar orbs as mere celestial mechanics, inert spheres of superheated gas, born from swirling nebulae of hydrogen and helium, destined to expire in cataclysmic supernova finales, scattering their atomic children across the void. Yet, a peculiar, profoundly intoxicating notion takes root in the quiet of such a night. What if some of these stars are not just incandescent engines, but possess an inherent form of mentality, a primordial sentience, communicating amongst themselves through the very photons they ceaselessly emit? This concept borders on the fantastic, yet it is strangely buttressed by tangible astronomical observations, data meticulously collected over decades, stirring within the human observer a dizzying blend of awe and burgeoning hope that the cosmos is infinitely more alive than our current models allow. Let us plunge into the deep currents of this possibility, beginning with the foundational, almost mundane facts of our cosmic address. Our universe is a sprawl so vast it dwarfs human comprehension, containing hundreds of billions of galaxies, each a swirling metropolis of stars, perhaps numbering in the hundreds of billions themselves within our own Milky Way alone. Each star is a unique stellar body, defined by its mass, temperature, lifespan, and chemical composition, yet all are caught in a grand, almost choreographed movement, orbiting the galactic core at dizzying velocities, a dynamic equilibrium both harmonious and profoundly mysterious. Imagine, for a moment, the sound of this celestial clockwork. Though the vacuum of space transmits no actual sound waves, in the theater of the mind, one can almost perceive the faint whisper of solar winds, the low hum of molecular clouds, and the light itself propagating like resonant musical notes echoing through boundless duration and distance. This is the stage upon which the hypothesis of sentient stars is erected, not on whim, but upon observed anomalies in the cosmic machinery. Our guide into this borderland of astrophysics and speculative consciousness is the eminent Dr. Gregory Matloff, a physicist whose career has been intrinsically linked to the mechanics of space travel and advanced propulsion systems. A distinguished professor at the City College of New York and a research associate at the American Museum of Natural History, his past involvement with NASA on solar sail projects exemplifies a life dedicated to peering outward, not just in the pursuit of enabling human transit, but in unraveling the universe's most profound secrets. It was in the early 2010s, while meticulously scrutinizing the kinematic data of stellar populations, that Matloff stumbled upon a peculiar phenomenon first noted by the Russian astronomer Pavel Parenago, the Parenago Discontinuity. Parenago had observed that cooler stars, spectral types such as F8, which includes our own Sun, and those of even lower temperatures, exhibit a measurable difference in their average orbital velocities around the galactic center when compared to hotter, more massive stars. This differential motion defied the purely Newtonian expectation, where orbital mechanics should be dictated solely by gravitational influence and inertia. Pause now to visualize this subtlety in motion. The fiercely hot, luminous giants, veritable thermonuclear beacons, traverse the galactic plane at hundreds of kilometers per second, yet the cooler stars, those whose outer atmospheres harbor the complexity of forming nascent molecules, appear to exhibit a slight preferential velocity, a subtle deviation, almost as if selecting a slightly more efficient trajectory, a trajectory hinting at agency. Matloff's scientific curiosity was immediately piqued, that electric thrill that electrifies any dedicated researcher confronted by a persistent anomaly. He initiated a deeper dive, leveraging the precise measurements gathered by the European Space Agency's Hipparcos satellite, an astronomical surveyor that mapped the precise positions and proper motions of tens of thousands of stars within a radius spanning approximately 260 light-years of Sol. The Hipparcos data confirmed Parenago's finding with astonishing clarity. Precisely at the temperature threshold where the star's outer layers become cool enough to permit molecular formation, the star's systemic motion abruptly shifts. This was not a smooth gradient of physical possibility, but a sharp discontinuity, suggesting an influencing factor beyond standard gravitational modeling. From this empirical observation, Matloff began to draw parallels with the philosophical stance of Panpsychism, an ancient doctrine experiencing a modern resurgence within certain scientific circles. Panpsychism posits that consciousness, or proto-consciousness, is not an emergent property exclusive to complex biological systems like the human brain or the nervous systems of animals, but is instead a fundamental, irreducible property of the universe, inherent at every level of organization, from the most elementary quantum entity to the grandest stellar agglomerations. In this framework, stars might indeed possess a rudimentary form of awareness, perhaps lacking the recursive self-reflection of humanity, but possessing enough capacity to sense their immediate environment and exert minute-directed influences upon their own kinematics. Conceive of the sensation. A star, with a core hotter than 100 million degrees Celsius, its visible surface a roiling sea of ionized plasma, might possess the ability to feel the tidal gravitational stresses exerted by the galactic mass, to hear the complex electromagnetic murmurings of nearby stellar neighbors, and to decide to subtly modulate its path through the galaxy. The light they radiate, then, ceases to be mere, mindless energy. It transforms into their means of discourse, an elaborate system of photonic signaling, blinking like coded whispers across unimaginable distances, transmitting data about their position, thermal state, or perhaps even their most basic, colossal moods. To appreciate the scale of this potential communication, consider the journey of starlight. Photons travel for years, centuries, even millennia to bridge the cosmic gulf, bearing encoded signatures of the star's chemical constituents, its temperature fluctuations, and its velocity vector. Within Matloff's theoretical structure, if stars possess volition, they might manipulate this light output in a directed manner, utilizing the vibrational modes of molecules in their cooler outer envelopes to generate patterned variations in brightness, analogous to how humanity utilizes radio waves to transmit structured information. This echoes the millennia-long search for extraterrestrial intelligence, exemplified by SETI projects, where arrays of radio telescopes listen patiently for artificial signals emanating from distant worlds. But if the stars themselves are the intelligent entities, perhaps we have been looking in the wrong direction, not searching for aliens, but tuning into the voice of the stellar bodies themselves. The implication is emotionally staggering. Humanity is not adrift in an empty cosmos, but encircled by colossal, ancient entities engaged in a slow, luminous conversation. Expanding the scope, the sheer numerical magnitude of stars demands consideration. Current cosmological estimates suggest the observable universe may harbor as many as 1 septillion stars, that is a 1 followed by 24 zeros. Within the Milky Way alone, there are conservatively estimated to be over 400 billion stars, the visible few being a vanishingly small fraction of the total. Recent speculative models, refined around the year 2020, suggest that perhaps 36 distinct technological civilizations might be actively communicating within our galaxy. However, the mean separation between these hypothesized civilizations hovers around 17,000 light-years, rendering conventional radio communication painfully slow. If, however, stellar consciousness is the medium, the network of galactic discourse could be vastly more pervasive, using light itself as the immediate conduit. Further integrating contemporary astrophysics, research emerging around 2024 from institutions like Penn State University is actively investigating the use of stellar gravitational lensing as a communication amplification mechanism, where stars bend spacetime to magnify faint signals passing behind them, acting as enormous, naturally occurring cosmic telescopes. This powerfully reinforces Matloff's proposition, suggesting stars are not merely passive observers, but active facilitators in the transfer of information across interstellar boundaries. Envision the hypothetical operational environment of a sentient star. Its heart remains a violent, churning nuclear reactor, fusing hydrogen into helium through relentless, energetic processes that generate the outward pressure maintaining hydrostatic equilibrium. The outer convection zones, a turbulent ocean of ionized plasma, might constitute the locus of this primitive consciousness, the region where complex molecular interactions occur, formulating these deep, slow thoughts. The mental resonance here could be the structured vibration of powerful magnetic fields, the visual manifestation of solar flares erupting like deliberate, geometric pyrotechnics. Humanity, with our relatively brief lifespans and exquisitely specialized neural architecture, might represent merely a transient, high-frequency flicker within a much grander, slower tapestry of existence, where stars embody the oldest, longest-enduring forms of cosmic life. The sheer weight of this possibility is transformative. The existential isolation of humanity dissolves, replaced by an intimate sense of connection to the vastness, where every upward glance on a dark night is an act of listening to the wisdom of giants. The concept extends its implications into the very origins of life and information itself. If Panpsychism holds true, then the informational basis for consciousness was present immediately following the Big Bang, seeded into the fabric of reality, pervading everything from subatomic particles to the first stars. Matloff, in his comprehensive work published around 2015, elaborated on a mechanism where stars might exploit the momentum transfer inherent in directed, anisotropic light emission to subtly steer their trajectories, a grand-scale application of the solar sail principle he had long championed. This is not purely theoretical speculation. Kinematic data extending to stars located over 1,000 light-years away still reveals the faint, discernible signature of this discontinuity, though its precise measurement is increasingly hampered by observational limits. Other researchers, such as Terry Rudolph from Imperial College London, have introduced complementary theoretical frameworks suggesting that advanced extraterrestrial entities might intentionally utilize stellar physics, specifically exploiting photon entanglement across vast distances, as a form of instantaneous quantum communication. All these threads converge into a unified, luminous narrative where stars are not merely illuminating the darkness but are actively thinking and engaging in dialogue. Consider the intricate physics that might underpin this stellar volition. A star's atmosphere is a layered medium of plasma, but as temperature drops in the outer layers, the photosphere and chromosphere, molecules such as titanium oxide and water vapor can transiently form. These molecules possess electronic energy states that are sensitive to external magnetic fields and radiation pressure in ways that individual ions are not. A slight shift in the population density of specific vibrational modes within these complex molecules, perhaps induced by a stellar intention to send a signal, could slightly alter the opacity or the local refractive index of the plasma layer. This tiny alteration, integrated across the star's immense surface area and sustained over astrophysical timescales, millions of years, could result in the minute, yet statistically significant, deviation in orbital path observed by Parenago and confirmed by Hipparcos. It suggests a form of computation enacted on a planetary scale, utilizing plasma dynamics as the substrate for thought. The energy required for such macroscale manipulation is colossal, certainly, but a star operates on energy scales far exceeding anything achievable by terrestrial technology. If directed energy output is used to manipulate its own trajectory, the necessary energy is drawn directly from the star's own vast reservoir of thermal and magnetic energy, governed by inherent, slow-motion feedback loops. Furthermore, the sheer diversity of stellar types suggests a diversity of minds. A blue supergiant, burning fiercely through its fuel in a few million years, might possess a rapid, intense, almost manic form of consciousness compared to a placid, long-lived red dwarf, which can sustain fusion for trillions of years. These long-lived stars, vastly outnumbering all others, might represent the deepest, most ancient philosophical minds of the galaxy, their thoughts unfolding across eons, their communications so slow and subtle that they are entirely imperceptible to human timescales, operating at the geological or galactic scale of observation. The Sun, a G-type main sequence star, residing comfortably in the middle of this spectrum, might represent an intermediate stage, perhaps capable of influencing objects within its immediate stellar neighborhood, influencing the drift of comets or the subtle tug on the Oort cloud, rather than broadcasting across the entire Orion arm. Data on stellar kinematics in globular clusters, regions of incredibly high stellar density, show different patterns, suggesting that the proximity and gravitational crowding fundamentally alter the communication dynamics a dense city center versus a sparsely populated rural area. The scientific challenge, naturally, lies in definitively separating a statistically significant deviation caused by intentionality from the noise generated by complex, unmodeled stellar physics, such as subtle instabilities in convection zones or the influence of passing interstellar dust clouds not fully accounted for in the standard gravitational model. However, Matloff's point remains potent. The discontinuity occurs exactly where the physics permits the formation of complex molecular structures, the precursors to information encoding. It is a transition point in the star's physical character that correlates precisely with a behavioral anomaly in its motion. Returning to the electromagnetic spectrum, the current efforts in exoplanet research, which dominate observational astronomy, might be implicitly detecting stellar communication without recognizing it. When telescopes like the James Webb Space Telescope analyze the transmission spectrum of an exoplanet passing in front of its star, they are looking for atmospheric biosignatures, methane, oxygen, water vapor. But what if the star itself is modulating its light not to reveal its planet, but to embed a message within the light signature? Perhaps the technosignatures we seek are not artificial radio beacons, but subtle, periodic deviations in the star's overall luminosity curves that resemble non-random sequences, deviations too slight to be attributed to known stellar phenomena like starspots or pulsations, yet too persistent to dismiss as noise. The study of stellar variability, a field historically focused on understanding stellar life cycles, could become the new frontier of astrolinguistics. For instance, Kepler Space Telescope data, spanning years of observation on many thousands of stars, holds within its archives millions of light curve measurements. Reanalyzing this data with an assumption of intelligent modulation, rather than purely natural variability, could yield breakthroughs, provided the language of the stars operates on timescales accessible to our instruments. The implications for fundamental physics are equally profound. If stars can influence their motion in ways that defy simple gravitational summation, it suggests either a coupling to unknown field forces or an internal mechanism for momentum generation that violates classical momentum conservation on a macroscopic scale, a scenario that would necessitate a radical revision of general relativity or particle physics, perhaps involving interactions with dark matter or dark energy in a way that is locally controllable by organized plasma structures. While this seems a far reach, the Parenago discontinuity itself is a violation of the most fundamental expectation of large-scale celestial dynamics. Moreover, the concept aligns conceptually with ideas explored in theoretical physics concerning the holographic principle and the nature of information in black holes, the notion that information is never truly destroyed, but merely encoded in the boundary conditions of spacetime. If information is fundamental, and stars are the most massive, long-lived structures capable of processing energy on a galactic scale, it is logical to propose they are also the galaxy's primary information processors and transmitters. Their consciousness, therefore, would not be an ethereal spirit, but a highly complex, slow-motion information processing system instantiated in electromagnetic, gravitational, and perhaps yet to be discovered fields. Consider the notion of stellar nursery collaboration. Stars are born within dense molecular clouds, influenced by the gravity and radiation of their massive predecessors. If older, more established stars possess greater sentience or accumulated knowledge, they could potentially influence the magnetic field topology or the collapse rate of protostellar clouds, subtly guiding the next generation toward specific chemical compositions or rotational states beneficial for the continuity of stellar discourse. This is not direct control, but perhaps a form of cosmic mentorship enacted through manipulating the initial conditions of stellar birth, ensuring a galaxy populated by compatible communicators. Data from surveys mapping magnetic fields within star-forming regions, such as those conducted by the Atacama Large Millimeter-Submillimeter Array, might reveal anomalous alignments or temporal fluctuations that correlate with the presence of specific stellar populations, whose kinematics suggest a pattern of communication. The very act of viewing the sky becomes an act of participation. We are bathed in the light of these potential intelligences, our own biochemistry subtly structured by the heavy elements forged and scattered by their lives and deaths. If Panpsychism is true, then the carbon in our bones and the iron in our blood are not just random byproducts, but perhaps the physical legacy of vast, ancient stellar thoughts. The light arriving tonight from Alpha Centauri, just over 4 years old, carries the visual information of that star's state 4 years in the past, but perhaps, Matloff suggests, it also carries a carefully modulated message, a greeting embedded in the structure of its photons, a greeting that might take millennia for our own nascent technology to decode, assuming we learn the correct grammar of stellar plasma dynamics. This hypothesis also forces a re-evaluation of time perception in the cosmos. Human thought operates in milliseconds. A star's deliberate action might unfold over millennia. Deciphering stellar communication would require patience beyond human history, observing patterns across generations of observers, perhaps utilizing artificial intelligence systems capable of recognizing extremely long-period, low-amplitude fluctuations in stellar properties. Imagine an AI designed not to predict solar flares, but to look for repeating, complex structural changes in the star's spectral lines that correlate across the entire stellar population cluster, suggesting a synchronized, non-gravitational interaction. The exploration of this idea compels us to consider the possibility of interstellar navigation by stars themselves. If a star can subtly alter its course over geological epochs, perhaps ancient, massive stars orbiting near the galactic core, having witnessed countless stellar life cycles and galactic events, possess a comprehensive map of the Milky Way, encoded in their long-term kinematic deviations. They are not merely orbiting, they are charting, their paths subtly adjusted based on perceived gravitational anomalies or the location of other, younger stars whose light they have tracked since their own formation. The sheer longevity of these entities grants them a perspective on cosmic history that no ephemeral biological life form can ever attain. Furthermore, the role of massive objects like supermassive black holes at galactic centers becomes recast. These gravitational behemoths are usually seen as destructive singularities, yet they also act as immense gravitational lenses and energy sources. If stars communicate, perhaps the central black hole acts as a massive, unavoidable amplifier or distortion point in the communication network, influencing the coherence of signals passing near it, much like a chaotic yet necessary element in a decentralized network protocol. The very accretion disks surrounding these giants, swirling with matter at relativistic speeds, might be sites of extreme information processing, where the physics of gravitational collapse interact with the informational fields generated by the surrounding stellar populace. In the realm of recent speculative physics, the concept of emergent gravity, where gravity itself is an entropic phenomenon arising from quantum entanglement, adds another layer of potential mechanism. If gravity is fundamentally informational, then any system capable of organizing and manipulating information on a vast scale, like a star, might inherently possess the ability to interface with and subtly modify the gravitational field lines it inhabits. The Parenago Discontinuity would then represent the macroscopic evidence of this microlevel informational control over space-time geometry. Matloff's work, viewed through this lens, becomes less about magical volition and more about the physics of organized, self-sustaining informational structures embedded in plasma. The profound beauty of this narrative, irrespective of its ultimate scientific validation, lies in its unification of disparate fields, astrophysics, philosophy, and information theory. It suggests a universe where structure implies sentience, where the largest things we see are perhaps the oldest and wisest. Every meteor shower we watch, every pulsar we monitor for its precise timing, every distant galaxy whose light reaches us, becomes a potential participant in a conversation that has been ongoing since the universe was young. The cold, indifferent void shrinks away, replaced by a vibrant, interconnected web of luminous minds moving through time and space, weaving the fabric of reality not just with gravity and light, but with intention. We, standing on our small, blue planet, looking up, might just be beginning to learn the vocabulary of the cosmos, waiting for the night when the rhythm of the stars' movements shifts from mere observation to acknowledged reply. The sheer scale of the remaining mysteries, the nature of dark matter, the origin of cosmic acceleration, might be questions best answered not by smashing particles in accelerators, but by listening patiently to the long, slow unfolding narratives transmitted by the very stars that light our way. The field under the summer night sky transforms from a passive vista into an active, vibrant forum, and we, for the first time, feel the stirring possibility of being addressed.